Okay, so let's chug through a couple of these. So question 1, we've got a definite indefinite integral here, and we need to determine what a would be using these partial fractions. Now, the first thing to note is that in between the 3x and the a, there is a negative, not a positive. So I'm thinking last year that was the trick that they used to catch a lot of people out, is that needs to be a negative in front. So all I have to do here to get it into this form is to multiply the top by this and multiply this side by that. And once I do that, that means that I can multiply these two together so that they have the same denominator. So all I'm going to do is that calculation. -1 times that bracket plus 2 times this bracket all over 1 plus x bracket 1 minus x. Next thing I'm going to do, expand this out. So I'll have -1 plus x plus 2 plus 2x all over 1 times 1 is 1. 1 times -x makes -x. That times that makes a positive x minus x squared. So these two terms are going to cancel out. Now the next thing I'm going to do is I'm going to collect my like terms. So I'll collect my x's first, 3x, and then I'll collect my 1's. On the bottom, I'll have 1 minus x squared. So we can see already that the bottom matches this bottom. We're happy with that. But in order to get this to match that, I need to break the 1 up into being a -1 so that this times that would make it positive. So that's how they catch you out, because the answer for the first one is going to be B. Okay, question 2. When using proof by mathematical induction, the inductive step, the one that makes it kind of special, is the one where you let n equal k plus 1. So remember that when we're doing proof by induction, our steps for this are tape. We test n equals 1, then we assume n equals k, and then we prove that n equals k plus 1. This is the inductive step. Okay, and then we evaluate. Okay, so all I have to do is let n equal k plus 1 in this expression here. So k plus 1, 2 bracket k plus 1 bracket minus 1, 2 bracket k plus 1 plus 1 close bracket. Now the first bracket I don't have to do anything with, but these ones I'm going to expand and simplify. So I'll get 2k for the first one, and then 2 times 1 makes 2, minus 1 makes plus 1. 2 times k for the first part, then 2 times 1 will make 2, plus another 1 makes 3. So the one that matches that is D, this one here. Okay, so according to the recent census, now a census means it's population data. So the mean hours worked by Australian workers is, so population mean is 35.6, and the sample mean is 36.1. Now, technically the symbols for this is that one and this one. Now, you'll remember that we used this one a lot in grade 9. That's because we generally give you a sample of data and you calculate the mean based on that sample. This is the population mean. So, which of the following is correct? The correct one for this is going to be this guy right here. Okay, so let's go down. Question 4. Consider points A and B as shown. Okay, so first thing I'm going to do for this question is I'm going to set it out in form of, what it is. Okay, so I'm going to have A. Now I'm going to have X, Y, Z going like this. And B, X, Y, Z going along the bottom. So this point of A is made up of 20Z and 5Y. 20z, 5y, no movement on the x-axis. And then B is made up of 10x and 12y. Okay, and that means it's got a displacement of 0 on the z-axis. So now if I want to find the midpoint of this, I need to chuck it in my formula of xa plus xb over 2, and then I'll do the same for ya plus yb over 2, and then the same for za plus zb all over 2. Okay, and so when I do that, 0 plus 10 makes 10 divided by 2 makes 5. 5 plus 12 makes 17 divided by 2 makes 8.5. 20 plus 0 makes 20 divided by 2 makes 10. So I'm looking for the one that has x, y, z. X, y, z. Wham, bam, thank you, ma'am. That's it right there. Okay, question 5 is a simple integration by substitution question. So we're first going to let u equal 3x squared plus 5. So du over dx is equal to 6x. So that means that du over 6x is equal to dx. Okay, and now I can substitute that in there and that in there. So you'll see as soon as I do that, it'll cancel out something at the front here, so I don't have any other x terms multiplying. So we're going to be integrating 4x u to the power of 3 with respect to u over 6x, which means this one can cancel that one. And then that means that the 4 and the 6 can cancel out to be 2 and a 3. So now what I'm really integrating, I'm going to move the 2 and the 3 out the front so they don't pollute anything else. Whoa, that got a couple of extra squiggles. Okay, so now when I integrate that, it'll become u to the power of 4 over 4. The 2 can cancel the 4, so I'm left with 2 on the bottom. It becomes u4 over 6 with plus Cody. Okay, so now I'm going to pop that back in, so it'll be 3x squared plus 5 to the power of 4 over 6 plus c, and that matches this one. Okay, next one. Z is this, W is this, so what's Z squared minus W? Okay, so I'm going to start by writing this out, and I'm going to expand my brackets straight away. Okay, I'm also going to put in the conjugate straight away. Now, the whole point of the conjugate is that you're reflecting it over this axis, which is why whatever is in front of I gets changed. Okay, because if this is my imaginary axis and I had something up here, if I do the negative of that, it goes down there. So it'll be minus 3 minus I. Now I can expand this here. 2 times 2 is 4, then negative 4i minus 4i plus 4i squared. Now anytime I see that, I know that it's going to be equal to negative 1. Okay, then this times that will give me positive 3. This times that gives me positive I. So this one will turn into negative 4. So it's going to cancel out with that one. This will simplify to be negative 8i plus 1 will make negative 7i plus 3. Now, semantically, we prefer it written with the real component in front. So that matches up with B. Okay, question 7, slope fields. Gotta love a slope field. So first thing that we're going to check is the easiest parts. So when x equals 0, it's undefined. Now, I can tell that because there's nothing on this axis. If it was going like that, you'd be able to see that it would have a value, which means that x has to be on the denominator. So this is an option, that's an option, that's an option, that's an option. Okay, that didn't help. Okay, next thing we're going to check is when x is any value other than 0, when y is equal to 0, the slope equals 0. Okay, so let's go through and check that. Things happen over here. You can see that that's squared and that's normal. So if I pick a negative value, fun things will happen. Really, you can test a couple of different coordinates if you're not sure, and just keep testing things until something works out. Okay, so the way we figure out what the slope should be is we use our formula, tan -1, and then we chuck in what that derivative is, so the dy over dx. So once I substitute this into these parts here, I should get an answer. Okay, and we're hoping that that answer will be equal to 0. So when y is 0, so that means that in the first one, if I let y equal 0, my denominator, wait a minute. Okay, so we're going to test this coordinate. So that is when x equals -1 and when y equals -1. Now we're choosing to test this point because when things are negative, that's when you're going to see a difference between them. Over here you can see that all my things are squared. So what I'm testing for is that it's going to either get rid of the negative and we won't care about it, or we will care about it. So let's start trying some things out. So if I put it into the first one, I'll end up with 5 times -1 over -1. And that's going to give me +5. Then I'm going to chuck it in this one. So 5 times -1 squared is equal to, or over -1. So that's going to be equal to 5 times +1, so -5. That's A, that's B. C is going to be 5 times -1 over -1 squared. That's also going to be -5. And then the next one, 5 times -1 squared over -1 squared is going to be +5. So you can see here that that gradient is going to be going off at a negative. So it can't be that one and it can't be that one. So it can't be A, can't be D. So let's now think about testing another coordinate. Okay, we're going to test this coordinate just above it just to see what happens. So we're going to be testing when x is equal to -1 and y is equal to +1. Okay, so let's start substituting in some values. So here we're going to have y1 squared over -1, which makes that to be -5. So it's not going to be that one. Let's test the next one. 5 times 1 divided by -1 squared makes that +5. That's the one that fits both of those points, so that's the one that we're going to keep.